In this video, we're going to be taking a look at prime and composite numbers. Now, the goal for this video is to be able to figure out whether a number is either prime or composite, and also find the prime factorization of certain numbers. Now, first of all, I want you to write down these two definitions in your notes. Okay, first of all, a prime number. What a prime number is a number that has exactly two different factors, one and itself. Okay, so in other words, there's not any other multiplication fact that equals that certain number other than, for example, if we're looking at the number 2, 2 times 1, there's not anything else whenever you multiply whole numbers together that can get you 2. Same with 3, same with 5, same with 7, same with 11. Okay, and then there's a lot of other ones, 13, 17, 19, 23. Those are all example of prime numbers. Now, the only even prime number is the number 2. Okay, all the rest of the prime numbers other than 2 will be odd. However, not all odd numbers are prime numbers. Okay, for example, the number 33, that's an odd number. However, there are more factors of 33 than just 1 and 33. Okay, there's also 11, there's also 3 as well. Okay, so make sure you understand prime numbers. Just because they're odd does not mean they're prime. Okay, but the only even prime number is the number 2. Now, moving down to composite numbers, this is a whole number greater than 1, okay, that has more than 2 factors. Okay, for example, the number 32, it has more factors than just 1 times 32. There's 4, there's 8, there's 16, and so on. Okay, so composite numbers, basically if a number is not prime, it's composite. If a number is not composite, it's prime. Now we're going to take a look at some examples of prime and composite numbers to kind of give you an idea, okay, of what they look like. And I want you to think about your basic facts, okay? However, do not think just because a number looks odd means it's prime. And it's really important to think about the divisibility rules that we went over in the previous video. Okay, and it's important to get your notes out and even compare those divisibility rules that you wrote down and compare them to these numbers. Okay, so take a look at 141. Now that's a really odd number to me. Okay, however, you know, I don't see it in any of my basic facts. Even 12 times 12 gives me 144. Okay, however, I do know the divisibility rule that if the sum of the digits equals a number that's divisible by 3, I know that it's going to be divisible by 3. So I know 141, if I add the 1, the 4, and the 1 together, that gives me a 6. So right away, I know that 3 is going to go into it. So that means there's going to be more factors than just 1 and 141 for this number. So this would be considered a composite number, 141. Taking a look at 84, okay, I know right away divisibility rule. If a number is even, that means it's divisible by 2. Very, very simple. Any even number is always going to be composite. Okay, so 84 would be an example of a composite number. Now, taking a look at the number 13, and whenever you have a small digit like this, think about your basic facts. Obviously, 675, 141, the basic facts don't really do you much good, but a number like 13, think about if there's any basic fact, if you're not really sure, that can go into that number. And then you also want to think about your divisibility rules. I think about the number 2. Okay, 2 does not go into an odd number. I think about the divisibility rule for 3. And 1 and 3 gives me 4, and that is not divisible by 3. Okay, I go to the number 4. I know that 4 times 3 gives me 12. 4 times 4 gives me 16, so that's not going to go. Think about the number 5. It does not end in 5 or 0. And I go through my divisibility rules, and I realize that any of the rules that I have do not go with the number 13, and I cannot think of any basic fact that equals 13 multiplication fact. Okay, so that means that this number 13 would be a prime number. Moving down to 54. I know right away 54 is even, so since that number is even, I don't have to really go through my divisibility rules at all. I know that every even number is going to be composite, so I can see that 54 is a composite number. Number 23, Once again, going through my divisibility rules. Okay, and think about my basic facts. I know 6 times 4 gives me 24, 7 times 3 gives me 21, even 11 times 2 gives me 22. Okay, go through my divisibility rules, and I see that there's not a divisibility rule that would go along with the number 23. Does not match up at all, and because of that, 23 would be considered a prime number. Moving to 675. Now I know this is an even number. However, just because it's I know it's an odd number. However, just because it's an odd number does not mean that it is a prime number. And I think through my divisibility rules, okay, and as long as one divisibility rule goes along with that number, that means it's going to be composite, and I see that this number ends in 5. I know the divisibility rule for 5 is that if a number ends in 5 or 0, 5 can go into it evenly. Okay, so 675, even though it's odd, still goes along with the divisibility rule. That would be a composite number. Now, taking a look at the number 41, once again, you want to go through those divisibility rules. I think about the number 2. It cannot go into 41. Okay, the number 3 cannot, because the sum of the digits is 5, and that's not divisible by 3. Okay, even going to 4, I know 11 times 4 gives me 44. 10 times 4 gives me 40, and I go through all my rules and I see there's not one divisibility rule that goes along with 41, and I can't even think of a basic fact that would equal 41. Okay, and because of that, this number would be considered a prime number. Okay, so this is an example of what prime or composite numbers look like. Now what we're going to do is go through a exercise or a way to figure out whether a number is prime or composite, just another way, and try to find the prime factorization of a number. Now I want you to write this down in your notes. Prime factorization is a way to show all the prime numbers that make up a composite number. Okay, and we're going to do this by using what's called a factor tree. Okay, so we're going to take a look at some numbers here and find the prime factorization of these numbers. Now I just want you to follow along as I do this first one here. So whenever we're trying to find prime factorization, we want to think of any type of multiplication problem that would equal this number right here, the number right up there. Okay, so I think about the number 15. Okay, other than 1 and itself. Okay, so I think about the number 15, and I know right off the top of my head that 3 times 5 is going to give me 15. So 3 times 5 is going to give me 15. Now I look at my 3 and I think about, is there anything other than 3 times 1 that can equal 3? I look at 5, is there anything other than 5 times 1 that would equal 5? Or if I can identify some prime numbers, okay, then I would know that there would not be anything that would equal that number. So I know that nothing else other than 3 times 1 equals 3, nothing else than 5 times 1 equals 5. So that means that 3 and 5 are both prime numbers. Okay, so this gives me the prime factorization of 15. They will not always be this easy. Okay, so 3 times 5 is the prime factorization of the number 15. Okay, I'm going to do one more for you before we do these together. Okay, so now we have the number 24. We want to find the prime factorization of this number. The key word is prime. Okay, think about factors. Okay, all the numbers that can be, all the prime numbers that would be multiplied together in order to get this number right here, 24. Okay, so I think about any type of fact or any type of multiplication problem that equals 24. It can be anything, and we have 2 times 12, we have 3 times 8, we have 6 times 4. We're going to go with 6 times 4. Okay, so we do a factor tree. We just simply write 6 times 4. Okay, now I understand that 6 and 4, those are not prime numbers. So because they're not prime numbers, I need to break them down even further. Okay, so I'm going to use a different color of ink for this next step. So 6, I break that down all by itself. I know 3 times 2 is going to give me 6. Okay, now whenever we have multiplication signs in our factor trees, we just drop those right down as well. Okay, now I've broken down my 6, now I need to break down my 4. And I know that 2 times 2 is going to give me 4. Okay, now I've come to the next step here, and I can see that the 3, the 2, the 2, and the 2 are all prime numbers. Okay, so the prime, I've come to the prime factorization of 24. So I would just rewrite this, and I'll just write the numbers in order. 2 times 2 times 2 times 3 gives me the prime factorization of 24. In other words, if I multiply 2 times 2 times 2 times 3, that would give me the answer of 24. Now I want you to write 36 down in your notes, and we're going to do this problem together. Okay, the first thing we need to do is think about a multiplication problem that equals 36. We have 2 times 18, 4 times 9, 6 times 6. We're going to go with 6 times 6. We'll write that down. Okay, so I'll write 6 times 6. We'll make our factor tree. Okay, now I understand that 6 and 6 are not prime, so we need to break these numbers down even further. Okay, so 6 and 6, I know that 2 times 3, it gives me 6. I'm going to drop down this multiplication sign, and then again 2 times 3 gives me 6. Now once again, I've come to a spot where all of my numbers here would be considered prime. Okay, and because of that, I have arrived at my prime factorization of 36, and I'll just rewrite this in order. Even though I have double digits here, okay, duplicates I should say, of numbers, I still write them all out. Okay, so the prime factorization of 36 is right here. 2 times 2 times 3 times 3 gives me 36. So you keep breaking the numbers down until you get all prime numbers. Now we're going to write this number down in your notes again. Okay, and we're going to find the prime factorization of 45. Now the first thing we want to do is think of any multiplication problem that can equal the number 45. I think about it, I know 3 times 15, 5 times 9, and we're going to go with 5 times 9. So 5 times 9 gives me 45. Okay, now here's a situation where one of the factors is prime, the other one is composite. So 9 is composite. In other words, there's another multiplication fact that can still equal 9. So I need to break 9 down still, and I can leave my 5 alone. And 3 times 3 is going to give me 9. Now whenever I do this, I can just simply drop my multiplication sign like we've been doing, and then I'll even drop my factor of 5 and write it down here. Okay, so I know that all my numbers here are prime, so I know the prime factorization of 45 is 3 times 3 times 5. And when I multiply these prime numbers together, that's going to give me the answer of 45. Now I want you to do the numbers 40 and 21 in your notes all by yourself, and when you are finished with this, you can press play and I will have the answers for you. So I want you to pause the video now. So here are the two answers. Okay, for 40 we have 2 times 2 times 2 times 5, and then for 27 we have 3 times 7 for the prime factorizations of those numbers. First of all, for 40 we broke it down 5 times 8. Okay, now the 5 was prime, the 8 was composite, so we had to break that down with 4 times 2. We brought the 5 in the multiplication problem down here. 4 was still composite, so we had to break that down even further. Okay, giving us a prime factorization of 2 times 2 times 2 times 5. 21 was pretty simple. We had to just break that down one time. 3 times 7, both 3 and 7 are prime numbers, so the prime factorization of 21 is 3 times 7. Okay, so that's how you figure out whether a number is prime or composite, and also how you find the prime factorizations of certain numbers. If you have any questions about this concept, please come and see me.